All right, before we do get into dilation, let me go over one more vocabulary term. Invariant. Invariant points. Ready? Invariant points. Points that do not move. That do not move after a transformation. All right, points that do not move. So I perform something. I perform a reflection, rotation, translation, and one or more of the points stays exactly where it started. All right, stays exactly where it started. All right, let's take a look at one here. We don't need to graph. Oh, if we do need to graph it, we'll see. Quadrilateral ABCD has those points. What transformation will result in point B? Point B being invariant, meaning it. Once I do take a look. Once I do a transformation that you're going to tell me, point B is going to stay 0, -3. It's not going to go anywhere. All right, it's not going to go any. Please don't tell me, oh, let's do a translation of 0, 0. No, I don't want that. All right, I don't want that. Let's do a rotation of 360. No. I need something a little bit better than that. Think about something in your mind. Reflection, rotation, translation. Probably not a translation, right? If I'm not going 0, 0, that's out. Rotation, if it's not 360, that point's going to move. So really what I'm really looking for is probably give me a reflection through a line that I could do. That 0, -3 does not move. So here's 0, -3, point B. It's not going to move. Give me a reflection where it's not going to move at all. Think about it. Where can I reflect over? So point B does not move at all. There's two choices I'm going to accept here. Two choices, and I'm going to go right to the numbers here. 10. The y-axis. Love it. So reflection over the y-axis. Point B would not move. It's invariant. I want something else, though, because you're in an above-average math class. Or give me another line I could reflect over other than the y-axis. Come on. And it would not go anywhere. What other line could I reflect over other than the y-axis? Anybody have it? I don't want to call in a number. Spence, you got it? That would be, there you go. Y equals -3. The horizontal line, y equals -3. Perfect. So if I reflected over either of those two lines, point B not going anywhere. All right, let's keep going. Give me a transformation where point D now, point D, 3, 0 would be invariant. 3, 0, meaning it's not going to go anywhere. 3, 0. Here it is, point D right here, 3, 0. Give me something where that would not move after this reflection. Because again, translations and rotations would move it. Give me something. What line could I reflect over here? 13. Over the x-axis. So reflection over x-axis. Or where else could I reflect it so it still stays where it is? A reflection over 5. X equals 3. Good. All right, so there's invariant points. Points that don't move after a transformation. Stay right where they are. All right, you ready to roll here? Last transformation. Last transformation. Dilations. You guys always think, hey, dilation, I'm getting bigger, I'm getting smaller. Here's what I need to talk to you about. Why, though, do you get bigger and smaller? Here's what a dilation is. I take a point, and I have a center of dilation. You'll always know the center of dilation. And either I get closer or I get further away from that point. All right? When you dilate a point, let's be real here. Does the point physically get bigger or smaller? No, it doesn't. That's silly. All right? The point doesn't actually get bigger or smaller. It gets further away or it gets closer from wherever we're dilating around. So take a look at my picture here. This is an example of a dilation with a scale factor of 2. Let me tell you what's happening. Scale factor of 2. Right now, the center of dilation to A is a certain distance. What I'm doing is I'm doubling that distance away from the center. Right? That's what's happening when I dilate by a scale factor of 2. I am doubling the distance away from the center. Now look at over here. Now I have a scale factor of 0.5 or 1/2. What's happening now? Everyone see my center to A had a certain distance. What am I doing to that distance? I'm cutting it in half. So that's why A is getting closer to O instead of further away. All right, that's what's happening. A point gets closer or it gets further away from whatever my center is. All good on what a dilation. It gets further away from a point or closer to a point. All right, so let's talk about that scale factor. A scale factor of blank results in an enlargement. So how do I know when the figure is going to get bigger? If your scale factor is greater than 1. Okay, greater than 1. So anything greater than 1, all the points are moving further away, which means the object's going to get bigger. It's going to get enlarged. What about if it's getting smaller? I'd like to say less than 1, but we don't have negative scale factors, so I'm going to make it a little more detailed. Ready? A scale factor between 0 and 1. Okay, there are such things as negative scale factors, but we're not going to get into that this year. So if it's between 0 and 1, it's going to get smaller. All the points are going to come closer. All good? All right, let's actually do some dilations with points now. All right, we have point J. First thing, I just want to make sure, because this will come in handy at the end of our discussion here. Point J, just let's make a note. It's 3, 2. Okay, so let's make a little note up there that point J is 3, 2. All right, you ready to dilate? So part A, dilation of point J centered at the origin. So our center of dilation is 0, 0, the origin. Scale factor of 2. Before we discuss what the actual point is J going to get further away or is it going to get closer to 0, 0? Further away or closer? If my scale factor is 2, is J going to get further away from the origin or closer? That's the first question I need. 8, further away. Everyone agree, because it's bigger than 1, J is going to get further away. It's going to double its distance away. Now, good news, you don't have to use distance formula when I say it doubles its distance. Here's how we figure out where J prime is. We're going to use slope. So everyone start at the origin right now. Up and over how many to get to J? Up and over how many to get to J? 8 again, Sophia?
2 over 3.
Up 2 over 3. Double that distance. So from point J, we're going to go up 2 over 1, 2, 3. And there is J prime. So we're going to use slope. We went up 2 over 3, double it, up 2 over 3 again. All right, do it another time. So J prime here. What do we have there? 6, 4. Okay, let's go back to J. Now I want to dilate it. Scale factor 1/2. Closer or further away from the origin? That's all I want to know first. Closer or further away? 11? Closer. So J prime should be somewhere in here, closer to the origin. Sophia, going back to you. How did I get to J again using slope? I went
Up 2 over 3.
cut it in half. We went up 2 over 3, but we're going half that distance. So if I cut that in half, that'd be what? Instead of up 2, we're going to go up 1. Instead of over 3, we're going to go over, cut it in half, 1.5. So we're going to go up 1, over 1.5. There's J prime there. And what would that new coordinate be now? When I dilate it by 1/2. 5?
1.51.
1.51. Good work. And last one. Let's dilate it by 3 now. Scale factor of 3. Further away from the origin or closer? 5 again?
Further away.
Further away. But now we're going to do it 3 times. So everyone ready? Up 2 over 3. There's 1. Up 2 over 3. There's 2. One more time. Ready? One more time. Up 2 over 1, 2, 3. There it is. And that point will be, if I dilate by 3, 13, 9, 6. Yep. So everyone see how we're dilating. We're using slope, and either I double it, I triple it, or I take 1/2. I'm not going to get too much crazier than those scale factors. All right. Can anybody find a little shortcut for me? This is why I had you write it down. 3, 2 was point J. 3, 2. I dilated it by 2. Look what it became. 6, 4. I dilated it by 1/2. Look what it became. 1.5, 1. And then finally, I dilated it by 3, and look what it became. 9, 6. Is there a shortcut I could do knowing the scale factor? So I don't have to go up and over, up and over, up and over, maybe? Is there? I can get to it like that? Anybody see the pattern? What's up, Kara?
Multiply the coordinates by the scale factor.
One more time. Go ahead.
Multiply the coordinates by the scale factor.
Whatever the scale factor is, multiply your coordinate by it, right? If I multiply 3, 2 by 2, it's 6, 4. Good. But hey, that rule only works if the center of dilation is the origin, okay? So if the center of dilation is the origin, you can multiply the coordinates by the scale factor. Okay? But again, I can't stress this enough. And I was nervous giving you this shortcut. You can only use it if you're dilating around the origin. What if you're not dilating around the origin? We got to do slope again. Okay, we got to do slope. We okay? All right, so now let's go to what happens if I don't dilate around the origin and I can't multiply anymore. Ready? So there's J again, 3, 2. But now look where I'm dilating. Around 7, 1. So multiplying it by 2 doesn't work. Are we all clear there? Multiplying it by 2 doesn't work because I'm dilating it around 7, 1. And I'll just put a little X there for my center of dilation. All right, so let's dilate J by 2. Further away from 7, 1 or closer to 7, 1? Is J going to get closer or further away from 7, 1? 11? Further away. Use your slope. Ready? I go up 1 over 1, 2, 3, 4 to get to J. Double it. Up 1 over 1, 2, 3. There's J prime. I can't multiply by 2. That's only around the origin that works. So J prime, -1, +3. Now cut it in half. Go ahead. Now cut it in half. I went up 1 over 4. Cut it in half now. Up 1/2 over 2. Let's see where you end up. Where do you end up for this one with 1/2? 10, where do we end up?
5.
Good work. And everyone ready to dilate by 3 now. And I know that, hey, whoa, everyone, hey, I know this is going to happen. When you go from the center to J, that counts as 1. So up 1 over 4, there's 1 trip. Up 1 over 4, there's 2 trips. Up 1 over 1, 2, 3, there's your 3rd trip. Okay, so that's you start counting right from the beginning. All right, don't start from point J and go up, do it 3 times. You start from the center of dilation and do it 3 times. And that's going to be what point? Dilated by 3, 1. Hannah?
-5, 4.
-5, +4. Okay, how do we feel? We all right with dilations? Using slope? You can multiply if you dilate around the origin. If not, we got to do the slopes. All right, we're doing points. Now let's go to figures now. Oh, there you go. Here we go. We know you're not going to get it. We're just wasting some cube. All right, let's dilate the figure by 2. Okay, first thing, is it going to get bigger or smaller, this figure? Scale factor of 2. Is the triangle going to get bigger or smaller? 11? Bigger. Why? Because the points are going to get further away from the origin. So, hey, you got 2 choices now. You can do slope from the origin, or because it is from the origin, multiply your coordinates by 2 and graph them. Right? Your call. Okay, your call. Do slope and double it, or take each coordinate, find out what they are, A, B, and C, multiply by 2 and graph it. It's your call. All right, go ahead. See if you can do A, B, and C, scale factor of 2. Again, you can use slope, up and over how many from the origin, and go that distance again, or figure out what each point is and multiply them by 2. And make sure you label them the primes now. Make sure you label primes. I'll come around here in a second, see how you're doing. And this is why your figure gets bigger, because those points are moving further away. And then go ahead if you want, feeling crazy, go ahead and dilate that 1, 2, 3, 4 pentagon by a scale factor of 1/2. So all your points should be getting now closer to the origin. That's why it gets smaller. So points are getting further away or closer in a dilation. Make sure when you're doing the scale factor 1/2, C primes -1/2, -1.5. Okay, make sure it's in the middle. All right, you got one more? All right, we got one more here together. Ooh, 2 cubes in a row. All right, graph and label A prime, B prime, C prime, the image of after dilation, scale factor of 2, but be careful here. We're doing it around point D, okay? Point D, so you can't multiply your coordinates now. You have to do slope. Make sure you start at point D. Hey, start at the center of dilation. Don't start at the point you're dilating. So let me do point A with you. From D to A, it's down 1 over 1, 2, 3. I double it, scale factor of 2, down 1 over 1, 2, 3. And plus, you should know it's getting further away. It shouldn't go on the opposite side of D. It should be getting further away from D. Go from the center of dilation and count. What is that garbage? We should be getting bigger. Real quick, before I let you go on your own, I made a note to myself here. You're going to need the distance formula on problem 30 tonight. So real quick, let's review that so you have it and I don't hear any excuses. Distance formula. I think it's going to ask you to find the perimeter of an object that you graphed. So you're going to have to use the distance formula. Graphing, not optional. If it says to graph, please graph. You guys have graphs in the back of your packet or a bunch of slices up on the shelf over here. All right. Compass tomorrow. Compass straight edge. Please, please, please. Compass straight edge. And you guys that came in later, all we're doing is the date of the test on the front of your packet. Move ahead a day. Okay, move it ahead a day. Whatever date I put on there. Yep. Compass tomorrow. Move your test the day ahead now.
Square bracket. No. Say bracket.